to 0, we got to expand it. Okay, to arrive at this, x squared minus 2x plus 1 minus 2x. Okay, so it simplifies to x squared minus 4x plus 1 equals to 0. Then you use your formula. A is actually 1, B is negative 4, C is 1. Okay, and then you press your calculator. I'll leave it to you to press your calculator. You should get the answers. Okay. Next question 6. Doctor, may I know why you're standing up? Okay. So, question 6, we cross multiply. questions with what I've already presented on the whiteboard?
Can I explain the last part?
This one? From here to here, huh? Okay, what I just did was to simplify, so I just put all this on the right side, bring over to the left. Okay, so 2x squared is here, negative 8x, then minus 5x, because bring the other side, so there's negative 13x. Then plus 8, plus 10 bring over, minus 4 bring over. Right? So that gives us plus 14. Okay? So some people bring things to the right, some people bring things to the left. So if you bring things to the left, then it will come like that. Okay? But the answer will come out to be yeah, equivalent equations. Okay? Any other questions? Right? Next we look at A and B, okay? Right, so we have 1 over x squared minus 9 minus 2 over 3 minus x equals to 1. I hope that most of us will be able to see that x squared minus 9 is x plus 3, x minus 3. Okay? That is by your factorization, your identity that you learned last year, your a squared minus b squared. So that actually gives us a plus b, a minus b. Okay? So we have this x minus 3 factor over here and this 3 minus x factor. They look the same but they are definitely different. Okay? They are not equal to each other. So we need to do some manipulation. So what you could do is to bring this negative sign or negative 1 into the denominator. Okay? Such that we get 1 over x plus 3, x minus 3 on the left, followed by plus 2 over negative 1 of 3 minus x. Okay? Or negative. Okay? This will help us to so-called flip this expression over here. I'll just write the bottom first. Such that we get negative 3 plus x, which is the same meaning as x minus 3. Okay? So that will be how we can make sure that we have a similar denominator. Okay? Before we combine it to the same common denominator. Okay? Then 1 over x plus 3, x minus 3 plus x over x minus 3. Okay, so we will get a single fraction on the left like this. Okay, then we can cross multiply, followed by expansion. So 1 times this is just this. Okay, I expanded the numerator already. So x plus 3 times x minus 3 will give you x squared minus 9 using the identity, which will give us x squared minus 2x minus 9 plus 7 raised to the left, so that will be minus 7, so negative 16. Okay, so I'll get x squared minus 2x minus 60 equals to 0. Then after you can use the formula. Don't think this one will factorize. This one, expand, alright? Minus 3 plus x. Okay? The minus sign is the thing that will cause the split. Okay? You cannot put a minus sign over here and then flip at the same time. It is not correct to write 2 over minus x minus 3 like that. Okay? Because I only bring down the minus sign or bring in the minus sign over here. Okay? But I have not yet done any expansion. So you cannot just bring the minus sign here and then already flip it. You only flip after the minus sign is being brought in. Okay? No, this is a negative 1. brought it down to the numerator. Yeah. Bring up. It's the same idea actually. Yeah. Okay, so yeah, write it down. What I did over here was I did an expansion. Okay, I brought the -1 or negative sign over here into the denominator. Okay, and then I did expansion to allow me to do the flip. Okay, we all know that we must do the flip, right? You agree on that?
Yes.
Okay, so that's one way. I did it by considering expansion. And now some of you are considering by factorization, whereby, okay, given this over here, same statement as this one, okay, then 3 minus x, you want to factorize out the -1, for which positive 3 factorize out -1, you get a -3 here. Negative x factorize out -1, you get a positive x. So I factorize out -1. Then after that, this -1 goes where? It goes up, negative becomes positive. Okay? And then we get -3 plus x. Right? For which it is the same as x minus 3. Okay? So two ways of thinking. Expansion and factorization, they are kind of going hand in hand, opposite of each other. Okay? Both ways are perfectly fine. Okay? Really up to you over what is something that's familiar to you. Okay? So this one is being brought down. Okay? And then yes.
He did a completely different method.
Then how? What's the method?
Yeah. Just see whether it's orthodox or not.
Last lesson I asked you to complete the table of values and then after that draw out the graph. Okay, so your graph should be able to look something like that. Most of the time when you're asked to draw a graph, it should be able to fill up at least half the graph paper. Okay, but of course nowadays moving on to national exam standards, they tend to provide you with the grid, right, such that sometimes maybe the graph doesn't fill up the entire space. Okay, but that is a general rule of thumb that we can follow whenever it comes to drawing of graphs on a graph grid itself. Right, our focus for today is in terms of solving the rest of the questions given in the notes that I've given you. So looking at part 3, right? Okay, we want to solve the equation 2x squared minus 4x minus 1 equals to 0. And last week when I ended off the class, or rather before I started the topic itself, we have come to an agreement that when I want to solve a quadratic equation, okay, which is what I have here, okay, if I'm drawing the graph, in this case 2x squared minus 4x minus 1, and having it set to be equals to 0, it means that what I've done is I substituted the y to be equals to 0. And hence, if we look for where y equals to 0 is, and that is the x-axis. So if we were to look at the x-axis position, and we identify the x-intercepts over here, I won't be able to solve the equation itself. Okay, so I want you to read the graph now, alright, to check what are the readings that you managed to get. Okay, let me just write the answer on the whiteboard. Okay, so from the graph itself, what's the value that you got? Let me just try to summarize myself here. Farid, what's your x value?
My x.
Yes, what values do you get? Okay, negative 0.2, and the other one?
2.3.
2.3. Okay, do we agree with these values? Okay, there is a range of values. Plus minus, what do you mean by plus minus? There is a range of values, acceptable values. Yes, there is a range of acceptable values. So, the range of values that will accept, okay, will be negative 0.25, negative 0.15 for this, and then 2.15, 2.25. Okay? Right? If you get something that deviates from this, okay, I would say that it's not as accurate, okay, so your graph drawing could be improved. My allowance over here is definitely on the stricter side, because I think we are coming to a practice, okay, so we should be strict with ourselves, rather than going for exam standard, which could be more lenient also, okay? Any questions? Okay, wait, actually I got 2.2. I wouldn't have gotten 2.3. I find 2.3 a little bit far. Okay. So these are the three values that I'm looking at. Questions? No? Okay. Next, we look at part 4. Okay, sorry, before we look at part 4, right? How is it that we can check our answers here? How will you put inside the calculator? What is the calculator? Put this equation in the calculator. Okay, so there's one method that I taught you all to actually do a checking. You can put this equation, A is 2, B is negative 4, C is negative 1, and then check your values. Okay, then after that, from the value itself, you see, okay, what is the value that you have given? Is it actually close to it or not? Okay, you cannot be giving me something that is very much exact to what your calculator is able to give. Right? Is it possible for my answer to be negative 0.23? Based on this graph? No, because we can only read up half a small square. Okay? You don't have your grid in your eyes, you cannot see it very clearly. Okay? So we are not able to give values that are like negative 0.23 based on this scale. Okay, so these are only acceptable answers. Right? And then you must make sure that these values that are given matches your graph. Because what an examiner will do is to check that this matches your graph. Okay? You're not trying to check whether it matches our answer or not. Okay? It must make sense to your graph itself. Even if you check your calculator and you realize that maybe your answer should have been negative 0.25, but your graph reads negative 0.2. Okay, it's still wrong, right? Because you did not give the correct reading from your graph. So it needs to be from your graph. Okay, so a general way to solve it algebraically, use your formula that you have learned today. Okay? Next, we look at part 4. The question wants us to find, using the graph again, the minimum value of y. So we're looking for the minimum point, and this is the minimum point. It is also called a turning point. Okay? In this case, it is very easy for us to read, and that will be negative 3. when y equals to 8, read the horizontal, okay, and then after that read downwards to the graph. Okay, please do that reading now and tell me what do you get when y equals to 8. Jaden, what do you get when y equals to 8? Read your graph.
Negative 1.35.
Negative 1.35
And 3.5.
and 3.5. I think 3.5 is a little bit far. Okay. I would accept negative 1.3, negative 1.4, and negative 1.35. Otherwise, I will accept 3.3, 3.35, and 3.4. Okay? If you do not get these values, I want you to check the symmetry of your graph. Okay? It might not be very well drawn up. Okay, I think there's room for improvement. Next in part 5, we want to write down the equation of the line of symmetry. We know that the quadratic graph is symmetrical. Symmetrical about what? It's symmetrical about the line of symmetry. And the line of symmetry is a vertical line, okay, that is right in the center, passing through the turning point. So you must be able to identify where is the turning point first. The turning point in this case is the minimum point, point that's at the lowest. Okay, so what is the equation of this? Sorry? X equals to 1. Okay, so that is an equation. Right? So you got to give x equals to 1. You cannot just write 1 only. 1 is a number, it's not an equation. Okay? Now next, we look at the very last part, which I want to introduce us to it first before we jump into chapter 5, which is much later. Okay, I thought that I can do this kind of question. Okay, so they say that by drawing a suitable line, we want to be able to solve the equation. Okay, we start off by looking at 2x squared minus 4x minus 10. We notice that there are some similarities between this equation given here with what we have already drawn. We drew 2x squared minus 4x minus 1. Okay, so how can we decide from here what is the equation of the line to be drawn? So that is the question that we want to answer first before we can really solve this equation by using our graphs. Okay, we go back to the understanding of how to solve this equation 2x squared minus 4x minus 1 equals to 0. Okay, we know that in order to solve this equation, we had to read, okay, where the graph intersects with the x-axis. And the x-axis actually has an equation itself. What is the equation of this line? What is the equation of the line of this on the x-axis? Y equals to 0, right? Okay, so actually what are we saying? We are saying the interaction between the curve and also the horizontal line y equals to 0. Okay, so when we say that 2x squared minus away 4x minus 1 equals to 0, we are looking at the curve equals to a line, a horizontal line 0. Okay, so when we say a curve equals to a line, okay, it doesn't quite make sense that we're looking at the interaction, or in fact the intersection between a curve and a line. Okay, so the intersection between the quadratic curve and the horizontal line gives us or gave us the solution to this equation. So now we want to figure out the equation of another line such that the intersection of the line, okay, a new line with the curve that we already have would give us, okay, the solution. Right? So how are we to determine, okay, this line, this new line that we have to draw? Okay, so let me just erase this first. Okay, so we want to figure out how to solve this using graphs. Okay, we have to have the curve on one side and then the line on the other side. But this is not the curve that we have already drawn. The curve that we have already drawn is 2x squared minus 4x minus 1. How do we make these two statements equivalent? Minus 10, if I were to break it down into numbers. Minus 1 minus 9, right? Okay, so do we see that negative 10 is equal to negative 1 minus 9, right? Okay, so this part here is already the curve that we have already drawn. We want another line. So, by manipulation, I'll bring the minus 9 over to the right. So the line that we will draw is y equals to 9. Okay, so that's how we manipulate the given equation that we want to solve. Okay, show how we get the curve equation to be placed inside it. Okay, how is it being subsumed inside? And then we bring the extra stuff over to the other side, and that will give us the equation of the line. Okay, and that is y equals to 9. So, drawing the line y equals to 9 into our graph.
Why so long?
Y equals to 9 will be here. Maybe I'll use it now. Not sure where the X is. Okay, so y equals to 9. Okay, so make sure that if you were to draw a new line, you label it. Likewise, the curve, you also got to label the equation. Okay. So with the line y equals to 9, we agree that when we say the curve is equals to a line, it is the intersection points that we're looking for. Hence, we can read off the graph. Okay. Well, you don't need to show any working. I'm just demonstrating how to read it. Read off the x-intercept, sorry, not x-intercept, the intersection over here, read off the x-coordinate, and then you will be able to get the solution. Okay? So, this is your y, okay? Draw y equals to 9. These are the values that I managed to get. Okay, those are my acceptable values. Again, how do we check these solutions? How do we check whether we are close to getting it correct or not? Yeah, we check algebraically, we can solve this, right? It's a quadratic equation, fully capable of solving. So, in order to check, solve algebraically. Or use your calculator. Questions? Yeah.
So I still don't understand the minus thing.
Don't understand this.
I don't understand
Here?
yeah.
Okay. What I'm trying to make here is I want the curve equation to appear. Because I know that when curve equals to line, it means that we're looking for the intersection point. I have already drawn the curve. We are not interested in drawing a new curve. Okay? With this curve, I want to know, okay, what is the new line to be drawn. From here, the curve equation appears inside. Because minus 10 is the same as minus 1 minus 9. You agree? Yeah. So, this is the curve. I already drew it. These are extra parts. I bring it to the other side. That will then form my line. Maybe I go. Anybody else don't understand? Okay. Let me reorganize myself. Okay, I repeat myself from the start, okay? Okay, let's be patient with people who haven't got it yet. Okay, now, I already have the curve, correct? Y equals to 2x squared minus 4x minus 1. When we say that we want to solve this equation here, equals to 0, okay? What do we look for? We look for the x-intercept. Okay? Why do we look for the x-intercept? Because that is where y is equals to 0. Y is equals to 0 is actually a horizontal line. So what I'm looking for is how the curve interacts or intersects with this horizontal line. When they meet, the 2 points, the x-coordinates give me the solution. Okay? So now, I have to solve a new equation. 2x squared minus 4x minus 10 equals to 0. Such that within this equation, I can actually squeeze out the curve equation which I already have drawn. Okay? So I want to figure out how will a curve that I've already drawn will interact with another line such that the intersection points will give me the solution to this equation. Okay? Because the original of 2x squared minus 4x minus 1 equals to 0, it is the curve with a line y equals to 0. Now I want the curve with another line that will help me to solve this. Okay? So it must come from this equation here. So the minus 10 split out to be minus 1 minus 9. Minus 9 bring to the right side. Okay? I will see my curve with a new line, new number. Okay? And this is where y equals to 9. Why is y equals to 9? Because my curve equation is 2x squared minus 4x minus 1 equals to y. Okay? So y must be equals to 9 doing substitution. Okay, so that's why I draw the line y equals to 9. Do you understand this concept already? Okay? Yeah. Yeah. This one, it's not the one. Go continue watching. Okay. Okay, we do one last question. One last question part before we go on. Okay, last one. We have 2x squared minus 4x minus 1 equals to x. This one is simple because we already see the curve equation over here. 2x squared minus 4x minus 1. Okay, we have the expression for the curve already found the left. Okay, so what is it that it is equals to? It is equals to x. That means that our line to be drawn is y equals to x. Okay? Y equals to x, what kind of line is that? It is a, I don't know why it says 0 lah, okay? It is a diagonal line, gradient 1, mx plus c, right? Plus 0. Okay? So, how do we draw this line? May not be simple for many of us. Okay? Maybe you need some guidance. Draw your table of values. Okay, just do simple numbers that you already have on your x-axis. equation y equals to x, y is -2, y, then this one is 1. Okay? So we will draw the line, plot out the points. Let me zoom out. Okay? So we draw plot the points -2, and 1 and 1. Okay? Okay, so we draw these 2 points. Okay, 1 and 1. Okay, so I marked out these 2 points here. Use your long ruler. Okay, connect through it. Make sure that it connects through your entire curve. Don't draw halfway. Okay, so this is the line y equals to x. Then with the intersection points, okay, we read downwards or upwards towards the x-axis, we will then be able to figure out the solution. Then tomorrow when we come back, okay, I'll run through the solutions. Right?